Al-Wishah. I'm a professor at the University of Jordan and a freelance consultant in water resources engineering. We would like to welcome you this afternoon in this session 19, and I'm honored to facilitate this session with the three distinguished speakers, starting from the right, Mr. Tamer Al-Asad, Mr. Jan Jansen, and Mr. Iyad Sahawne. If I want to go through their short bio, Mr. Tamer Al-Asad is a water utility governance and infrastructure expert. He has more than 20 years of extensive experience working for donors, private and public sector. Currently, he is working as Deputy Chief of Party for Technical Water Utility Expert with a USAID project with Chomonix. And previously, Mr. Al-Asad worked in several full-time management positions with international and local organizations. He is a Herbert Humphrey Fellow in Urban and Regional Planning from MIT and holds MBA and MS in Water Resources and Environmental Engineering. And he authored more than 25 publications in international journals and conferences. Mr. Tamer, you have about 20 minutes to introduce your presentation. You might either take the or chair.
This one. Hi.
بدك ماوس؟ Okay. Okay. تعال محلي. I forgot to mention that this is about non-revenue water system here, this session 19.
So this could work, yes. Thank you, Dr. Radwan.
Use that one and
Yeah, I can see from this way. Thank you, Dr. Radwan. So today I will talk about the different non-revenue implementation models that been actually used in Jordan to manage non-revenue water reduction. Some of the models already presented yesterday by Miyahu team. Luckily also we have Engineer Iyad, who was one of these models in Jordan. So in general, as you know, non-revenue is still one of the biggest challenge and constraint in Jordan. And everybody knowing that the amount of non-revenue water is making a big financial stress in Jordan. Last year's, despite all the investment, we still have the non-revenue water around 50% at a national level. It varies, of course, on the governorate level. There were several programs and master plans developed, including the non-revenue master plan, national strategy, strategy for non-revenue reduction, plus the infrastructure master plan, in addition to other initiatives and projects in non-revenue water. Despite all this, if we go back historically in Jordan, the lowest non-revenue water nationally we had reached is 42% only. And when DC came in, frankly speaking, 2013-14, because of the additional supply, non-revenue waters went up and has continued to be up. And it was difficult to reduce. Also, there is a huge investment made last years. Specifically, for example, by USAID, more than 350 million FARA, and actually it was increased to around 430 this few months ago, and there will be more investment coming by the different donors from German, EU, and World Bank. The investment could be even in around 1 billion. But the question, how to use this huge investment in the right way to achieve the non-revenue reduction. Before presenting the different models that being used in Jordan, I will just go quickly over the key challenges, because it's important to understand the challenges and the key context situations that guide which model is better to use for the context and the challenges we have in Jordan. First of all, we still have an issue in the institutional capacity in terms of having the qualified and required human resources to manage the whole related activities and operation to non-revenue water. There's still a need to do a lot of improvement on the systems and having the equipment, although there's been investment, but still there is some gaps. And particularly, there is an adequate financial resources for mainly the sustaining activity, the maintenance activities, not the capital investment. On the monitoring and the measurement side, there will be some improvement in the measurements, but still there is a lot of resources or some primary systems not monitored, and no enough measurement in terms of pressure, plus inadequate maintenance of these instruments. When it's come to the commercial losses, we have a problem with still aging meters, particularly for the customers. For example, we have a lot of customers' meters that is dysfunctioning in many governorates, broken or not working or very old. Still, there is a lot of illegal use and difficulty to control that. Plus issues in the billing and even mapping of the customer. There is several projects done to map the customers, but still some governorates, they have an issue in locating their customers. So this is the reality we have. Plus on the physical losses, when you talk about the system, still there is a lot of system not structured, high pressure levels, high variations in terms of supply period. Most of them is intermittent, but range between 1 day per week or per even 3 weeks. Some governorates in some areas could reach to 3 days per week, but that's limited areas. And of course, the infrastructure, part of it is aging, but although there is a lot of investment is done, still there is weak asset management, and actually systems are not maintained as designed in terms of hydraulic of the systems. On the top of that, as I said, intermittent supply is there, which make targeting the non-revenue water even more difficult. And limited water resources is becoming more and more, particularly in the last years with more droughts. We have more limitation in the supply, and the coming years would have also similar difficulties. Now, within this context and these challenges, the questions will be how in Jordan we really can succeed in reducing non-revenue water, considering these challenges, but also considering there is a lot of investment coming. So which option would work first? Is it do it as currently is done, or is do it by modifying the approach using the internal resources, or private sector? Before that, as you know, because some of you maybe not from Jordan, we have currently 3 water companies managing the whole governorates in the north. We have Yarmouk Water Company, and then in the middle we have Miyahona Water Company managing each one 4 governorate, and in south Aqaba Water, which has a management contract also to manage the southern governorate. On top of that, we have the Water Authority of Jordan, which is by law is responsible for providing the water and wastewater services and developing the water resources, and it's the owner of these companies. Especially, except for Aqaba, Aqaba has a partial ownership from ASISA 15%. But all is at the end is a state-owned enterprise in international language. So it's a public entities, even if it is a private company, but it's owned by the government. All of them has the mandate to provide services, water and wastewater. They are Miyahona and Yarmouk. They are what we call them operational companies. Aqaba has a higher responsibilities to do the investment, but for Miyahona and Aqaba, all the capital investment, the major investment is the responsibility of WAJ. Now, within this context, over the last years, there have been 4 different types of model actually implemented in Jordan, either fully or actually in the development stage. The first model, which I call it here internal model, which is basically executing the non-revenue activities by the utility resources through the internal resources only. This is mainly done to some extent in Miyahona, and it is and currently under execution, where it's basically using their own resources, but also recruiting some additional staff when needed. It includes some incentives scheme. All the procurement is done and the maintenance is done internally. Plus, the capital investment for this, of course, is funded by the donors. The current one, which is mainly executed by Miyahona, it was presented yesterday, is funded by USAID. So this is the first model. The second model, which we call it, based on the international terms, a fully performance-based contract, which means you give a whole area, part of Miyahona or part of Amman, and there's ongoing discussion with the World Bank on that, frankly speaking, since 4 years, but they're still not concluding this even term of reference, and I'm telling you why later on. This is basically giving like 25% of Amman fully for performance-based contract on a long-term contract, more than 8 years, could be even, the longer is better. And this gives all the responsibilities for operation and maintenance of that part of Amman to that contractor. So you need to understand what that means. Giving whole responsibilities, operation, maintenance, billing, and even investment. But investment has to also usually, you need to have another source, some contribution from Miyahona through Miyahona or donors. But private sector also has to bring some investment. They need to bring some investment and their know-how. So this is actually since 4 years under development. Is still till now is not issued for tender, and my personal expectation it would take them another maybe years to do that. I'm telling you why later on. The third model, which I call it partial performance-based contract, this has actually completed just recently. My colleague, Engineer Riyad Sahauni, he was the non-revenue expert in that project. He worked for 2.5 years on that project. This project is basically you bring a private sector to partially be responsible for some of the O&M, not all the activities. You give them for O&M. And it was designed a short period, 2 years plus, basically 2 to 5 years or 3 to 5 years, but with optional performance extension. This has the whole capital investment is mainly done through Miyahona with partial minor investment from the contractor. This also, the whole foundation activities, which basically in terms of restructuring the system is not responsibility of the contractor, was done by Miyahona before, so you give them a restructured area. Already a system that is restructured in terms of distribution zones and DMAs, but there is also responsibilities for Miyahona in terms of maintenance was done by Miyahona. In terms of illegal investigation, when they detect an illegal use, the actions has to be done by Miyahona. Plus supplying the system is for the distribution zones is by Miyahona, but distributing the operation side is by the contractor. The last option I would call it, which I call it focused performance-based contract. This one is a hybrid between the internal and the partial performance-based contract. It's similar to internal, except that you could outsource specific small activities, like outsourcing the leak detection activity, outsourcing the maintenance activity, outsourcing the billing. You outsource by piece. Very focused piece, you know the scope and you know the targets. Good. So this is actually also used in Aqaba, but partially actually implemented in Miyahona. Still Aqaba is under implementation. Where is the other side? Yeah. If I want to go now to the assessment of these models, Usually there is no right answer and wrong answer for any of the models, except if we understand the context and the risk, how it's allocated. To do this, I developed, let's say, different criteria that are grouped under 4 areas: execution and management, operational and situational, that's related to the situation, plus the capital investment and the cost and the capital investment, plus the result and incentives. Under each one, there is sub criteria. I'm not going to discuss these. I will go to the next slide to show you initially how the result, when you apply in each sub criteria for each model, and how it's look. And this is important because some of the models will look good for some of the criteria, some of those will not look good. But there is, at the end, an overall view on which model will work better considering the whole criteria and risk allocations and the context that we have in Jordan. If we take the first one, execution and management, and if we look to the different sub-criteria, for example, you will see the fully performance-based contracts. If you look to it's the one that has the most negative one in terms of execution and management. Why? Because it's very complex, the model. There is difficulty of less flexibility to change the contract and the approach because it's outsourced. Once the contract is there, it's become difficult to do VOs. There is political resistance because it's politically it's like you are giving it to private sector. In Jordan, there is, I would say, always bad sign out that. Plus, the duration of development of such contract is long. I'm telling you till now, since 4 years with the World Bank, is the tender is not issued. 4 years. If you look to the other models, you will see that the internal has the most positive one, but also the focused performance contract has a good. Why? Because you have more flexibility to change the approach as you're developing it, because there is no contractual requirement on, like the case of the performance-based contract, the fully one. Even with the partial one, once you have the contract is executed or signed, changing it is becoming an issue. Also, ability to recruit staff. The good thing is for the performance-based contract, when it's fully or partially, it's better than the internal, of course. But if you do a focused performance contract, you can recruit staff through this targeted, focused. And if you look to the, for example, ability to procure, of course, under the fully performance contract, it's only private sector, so they are easier to do their own procurement. It's low under the partial because there is a lot of control, as the current case between the utility, Miaona, and the contractor. It's moderate for the rest. When it goes to the operational and situational context, same issue. The fully performance contract is very problematic because there is high risk in terms of intermittent water supply. Niyahuna can't guarantee sufficient water resources to tackle the non-revenue issue. And this actually one of the major issues that any operators, and my colleague Ed can show you a lot of site, if you don't have sufficient water, it will become difficult to actually execute non-revenue water. And you want to outsource fully to the private sector, this very critical risk. If you cannot manage it, it will be a big issue. The other one is actually the limited availability of the informations in terms of the current condition of the assets and sometimes the customers that make the risk on the private sector high. So this risk cannot be managed because they will increase the prices. So when it's compared to the internal or the focused performance-based contracts, you can manage this because it's an internal issue. It's not you put it on the private sector, which will create problems, claims, and VOs, and all these things. So with this, also you can see who is winning. If you go to the third group, which is related to the cost and capital investment, again, with the fully performance-based contract, the capital investment risk is high because if the private sector want to invest with the lack of information, it will be the highest. But it is the lowest when it is internal because it's your issue. You can do the investment as needed, based on the improvement of the informations. Same with the focused, the performance is still not that bad, but the internal is better. When you go to the value of contract, of course, and to attract executor, under fully performance contract, you need to have a large contract. Small contract doesn't work. While internal or focused performance-based contract, small contract can work easily, and you can scale it, particularly with the focused performance-based contract. Fully performance contract has to be large and long, so it's more costly and long to develop. The last one is about the results and the incentives. Now, if you look at the guarantee of the result, achieving the set targets, the first three is actually almost equal. There is kind of balanced. The focus performance contract is more guaranteed because you are addressing each activity separately, so it's easier to manage the results and ensure that you get them. When it is a full package like the fully performance contract or the partially, it's questionable. Under internal, because of the limitation that the internal alone, in terms of lacking of the resources and the financial support, it's also, I would say, moderate. If you go to the time to achieve that, usually the internal resources, it is the high. It will take the longer time because you don't have the sufficient resources alone. I'm talking about the internal resources. But it is, of course, much quicker if you have the focused. You will get the resources you need when you need them. And, of course, under the fully performance contract, compared with the partial. I'm almost concluding. When it's coming to dispute on incentives calculations, this is a big issue, and I think under the fully performance contract, of course, there is a big issues on that. Same with the partial, and I think my colleague can tell you more on that. It's very difficult, and because of the changes sometimes of the operation conditions, the supply period and quantity, etc., it will make a lot of dispute on the incentives. And of course, at the end, the cost implication. I'm summarizing all of this in total, just to see the context. In total, you will see that the focus performance contract has the best or the least negative, let's say, action results compared with the fully performance contract, which has the highest negative result according to the 4 groups. What that mean? Would that mean that private sector participation, yes, it's good, the private performance-based contract, but within the context of Jordan, within the context that we have, going with just contract actually is really hard to succeed. A proving case we already have is the partial performance contract, which is concluded, and yet can tell you that this does not work with the current context. It will not work actually. And it was clear because this actually assessment, I would say, I developed 2 years ago and still valid. Still valid. And it's actually confirming what's concluded. And I think the internal could work, but the best one is to have a focused approach. And actually, this is the conclusions without going into more details. But that's the reality because you can, it's about how you allocate the risk and how you can manage them. Hopefully, it's on time.
Thank you, Engineer Tamer, for this interesting presentation. We will wait for the questions till the end of the session because there is connection between the speakers, so I think we will wait to the end of the session to collect questions from the audience. Our next speaker is Mr. Johnson. Mr. Johnson is a Belgium national. He's a senior expert for project and advisory work in water infrastructure with more than 35 years of experience in water sector reform and change management, public-private participation in water and sanitation. He has experience more than 15 years in the World Bank, 12 years independent consultant, and he led large multidisciplinary team in advisory support to client government and gain extensive experience in multi-donor project preparation and implementation. He is also specialized in water utility reform and around, including non-revenue water management, and he has experience in Africa, North Africa, Middle East, Caribbean, and Eastern Europe, Central Asia, and Asia region. You have 20 minutes, Jan, to present your presentation. Thank you.
Thank you, sir, and thank you also for this introduction. I feel very modest after this. First of all, it's a pleasure and an honor to be here and speak for you and give a short presentation. I've been in Jordan already a few times. Also, I've been involved in the Aqua Water Week. So it is a really pleasure for me to be here and be back and share some experiences. Second, I would like to apologize for my colleague Javad Kolzo, who was basically the main author of this presentation, and he was planned to be here, but he was called away in Tanzania for an assignment which he could not postpone anymore, and that's why I'm here to present, and I will do my best to replace him. So the presentation is part of an assignment which GOPA is executing with support of BMZ and KfW, and it is a consulting service for the preparation of the feasibility study to see where to invest a certain amount of money to reduce in a sustainable way non-revenue water. The main tasks was to see how this can be best approached. And after a long internal discussion, we decided to use a fuzzy methodology to select the most appropriate area to go further into detail to see how the investments can be carried out. So on the basis of a countrywide screening, we identified a long list, and the text is here not correct, a long list of potential areas where this investment program could be implemented. So we decided to use a multi-criteria decision-making, and the previous speaker already made a reference to that. And I must say that in the water sector, this MCDM, to use the acronym, is not really very often used. So I think for the application we are presenting and sharing with you is the first time this approach is tried to be applied. In the family of MCDM methods, we were advised to use the Vicor MCDM method, which was developed in the university in Bosnia-Herzegovina. And the MCDM method was then linked with a fuzzy logic to decide what of the areas was the most appropriate for an investment. So the first thing we had to do is decide on the criteria or the features which we thought were interesting and critical to identify the best area where to invest as a first step. That's of course very subjective, and it is based on the professional judgment of the people involved. Second, we need to give a weighting factor to this criteria and to decide which one we think is the most important. And on three, we apply the methodology. At the end of the day, the system with the highest score was considered as the best or preferred system among the alternatives. Now, just for the sake of those who are not fully familiar with the word fuzzy, so fuzzy stands in opposition to Boolean logic, one or no, the binary situation. The fuzzy is much more complicated, as you can see. It's just a slide to just put the word fuzzy in perspective. So the fuzzy Victor system is basically trying to give a weight to a number of criteria. And we have identified 9 criteria to develop or to characterize a potential system to accept the investments. Then the model, the software, calculates alternatives and comes up with a compromise. And that is the logical framework. So each system has a number of features, criteria, which we identified in common discussion. We give them a weighting factor, and and the system calculates a score. And the highest score is the winner. That is the list of the long list we finally came to after countrywide assessment. So you see it's quite comprehensive. And that was the beginning. Data collection, as mentioned before, but the previous speaker, was an issue. Not that simple, but we managed finally to obtain the necessary information. And then there comes the step weighting of the criteria. That was really the most challenging exercise. I pass this slide quickly and I go to this one. And here you see the 9 criteria which we finally ended up to investigate. Service coverage or access, the water consumption, staffing, non-revenue water percentage, and immediately noting that non-revenue water expressing as a percentage in an intermittent system is quite, well, a challenge and conceptually not possible. Active meters, the network condition, the quality of the service, the costs of operations, and the social factor, is there an issue with the refugees? And you see what we did as a baseline. We gave, obviously, non-revenue water the highest weight, and then with the others in secondary, network condition, operating costs, and metering. So that was the baseline. And then we had to look at, for each criteria, is it ascending or descending? That means, is the highest value the best, or is the highest value the worst? And reversely, obviously, the highest the worst and the lowest the best. And for each feature, we identified a KPI, and we calculated that. So that was the input of the system. Now, after that, we were saying, okay, how robust now is the conclusion? And we decided to investigate 5 scenarios in addition to the baseline, the scenario where we started with. And what we did, basically, we looked at the 3 main criteria is availability of active metering, the network condition, and the operating costs. And that was not without a reason, because we try to introduce the concept that we have an amount of money eventually available, and what we would like to achieve is the maximum achievable result for a given financial basket available. So we thought network condition is really important, and the cost of operation, of course, also. And what we did, we run the system a few times, and that is the scenarios. And you see the baseline was non-revenue was the highest. Scenario 1, we put network condition, and in fact, we kept that throughout the analysis. And we also looked at the operating costs, and we also looked at metering. And what we found is quite interesting, that independent of what we did, we always came out with the best of the selected area as the most, let's say, potential interesting for our exercise. So in fact, the analysis shows that the results of the calculation was quite robust, and that the 3 criteria, non-revenue water, network condition, and metering, are the 3 main features which you have to address. So on this, I would like to come quickly to the conclusion. That's the same slide. Conclusion is that applying such a fuzzy multi-criteria decision-making software is quite interesting and can be definitely applied in the water sector and select areas where the best investments can be achieved from the point of view output-based, results-based. A sensitivity analysis which we carried out showed that applying this software is yielding quite robust conclusions, provided that we take the 3 main criteria into account. So the overall conclusion was that the fuzzy vector MCDM method, which is not really applied in the water sector so far as the literature is showing, is an interesting software to be applied, where to, when you want to investigate, where to put your priorities in a most effective investment program. Thank you for your attention.
Thank you, Jan, for this very fruitful and concise presentation. Now we move to the third speaker. Third speaker is Mr. Iyad Zahawi. Iyad has more than 10 years of hands-on experience working on multinational engineering and service professional in the field of infrastructure development and water utility management across middle to large size complex projects. He has extensive understanding to local and regional markets and job with all phases of multi-billion dollar program, including non-revenue water reduction, operation and maintenance. Recently, he was assigned as non-revenue water manager for the first of kind project in building partnership with specialized contractor from the private sector towards reducing and sustaining reduction of non-revenue water, choosing the area of capital Amman. He holds a bachelor degree in mechanical engineering and he is a certified project PMP and degree in associate of leadership and energy and environment. He is also accredited professional engineer and trainer in Jordan. Yeah, you have 20 minutes. Please present your presentation.
Okay, good afternoon, everyone. Since I am the last speaker, I will be briefly introduce the presentation. Our presentation today is to introduce an innovative solution to improve the operational efficiency of water systems using a flow control valve that called the MERIC solution. Briefly, the MERIC solution is a technology owned by a patent, and it's have a watermark from the Australian Water Regulatory. The distributor and the implementing partner for the MERIC solution is a company called BSAN. It's a Canadian company based in Canada and have several regional offices, specifically in the MENA region and Gulf region. The flow control valve of the MERIC is developed to provide a constant preset flow rate regardless of the pressure fluctuating before and after the preset point that are designated to maintain the hydraulics in the operation and maintenance management of water solution system. Simply speaking, how it's work. Actually, the principle of working is that this device is elegant from its original base of being only a rubber custom-made solution. As we know, the flow control valves have different challenges, specifically in the intermittent water supply and sensitive hydraulic conditions in our water distribution systems. So this solution is made in order to operate it under low pressure through the large orifice, and then on the other side, on the other condition of high pressure, it became smaller and smaller orifice. The patent actually is provided because the geometry and the material composition of this rubber constant flow valve is custom made by the end user through providing the pressure profile and the presetting values. After that, there is a custom made geometry for this rubber with custom made material composition that are manufactured in Canada in order to provide a flow control valve that life sustain and it need minimal level of maintenance, as we will show in the next slides. The feature of the solution is that it's respond instantly to the changes in the water pressure, which is a problem in Jordan and in all the water network that are running under the intermittent water supply or under the supply and demand distortion patterns. It's highly reliable due to their simple design. As I said, it's just a wrapper with elegant design, and it become with a spectrum of products, as we will see. No adjustment is needed, self-maintained, tamper-proof. The lifespan exceed 15 to 20 years, and it has the mark water quality assured. Plus, it have a wide range of flow rates, as we will show on the performance curve next. The innovation of Marek solution, it's variable protection for the flow rate sensitive facilities, which is faced by Jordanian water sector. Automatic, maintenance-free, and self-cleaning, which is compatible with our water quality requirement. The lifespan, as I said, 20 years. It's a compact product that have a broadest range of connection type, screwed, flange, adapter, and etc. How it's work, as we said, it's a flexible rubber control ring with orifice. It's respond instantly to the fluctuating of water pressure profile, and simply it's custom made based on the end user requirement. The specification, as we say, it have a different range of pressure as we shown in the presentation. The flow rate accuracy, it depends on the pressure profile and the placement location in the water network, but it's generally speaking within plus or minus 10% of the actual flow rate. The body size, it's from 6 millimeter up to 300 millimeter, which is flange mounted in storage. As we see here, there is a wide spectrum of rubber solutions. Each one have its high pressure or low pressure, high flow, low flow, depend on the requirement of the water utility or public service utility. The application of the Marek solution through different area of expertise and industries. I will briefly introduce this 7 area of expertise that can be applied through the Marek solution, and finally I will present some reference project in Gulf region and Europe. For the water authorities or water utilities, you can use it to maintain the main pressure, as we said, regardless of the fluctuating before and after the preset value. Extend the water meter life, which is a problem here in Jordan, specifically at the customer side level, to prevent the unpelled water and other relevant issues. It's facilitate the distribution of water over a vast distance, reducing the cost of maintaining and operating infrastructure, and restructuring the supply to promote the payment and overdue bills, and maximize the revenues through providing proper management of customer metering and bulk metering, starting from the source and end with the tap. In the water treatment industry, there is a various processes for which the water should be controlled, whether at the water or wastewater level. It's control the back wash water, control the flow rate through all the water cycle in the treatment. It's used in the chlorine concentration measuring equipment, the dosing equipment, limiting the peak flow through the ultraviolet fertilizers, chemical dosing controlled, which is also an application here in Jordan that can be used in the pump stations. It limits the maximum flow rate to be aligned with the manufacturer requirement. And finally, it can be used in the RO treatment plant, which recently expanding here in Jordan. In the pump protection, we are talking about 2 main issues actually to protect the centrifugal pumps. First, to ensure that it always running in the best efficiency point duty zone, and there is available suction before the pumping point, which is calculated through a net positive suction head. The Marek solution can be used to limit or maintain a fixed preset value. It can be a protection tool for the pump operation. Specifically here, if we are saying in Jordan, the water wells always suffering from over pumping or overloading due to the fluctuating in the power rate that's come from the power companies, and there is no monitoring automatically by the operators, so they are also demanding for an observer in order to control the suction and the initialization of power operation and pump operation. Marek solution can be placed simply with a preset value that can adjust the control flow valve in the dry operation and the wet operation in order to avoid the pump failure. Also in the power and pump protection, it can be used at the submersible centrifugal pump level to avoid the upthrust damage, and in the above ground centrifugal pump where the suction is sufficient, but it can protect the happening of the cavitation. Also, protection from the overpumping of the bores and protection from overloading of electrical motor, as I just say. In the irrigation, and we are in Jordan familiar with the problem that half of our water use demand is go for the irrigation use. This is why we need to handle the water networks of irrigation as we are handling the water distribution systems in Jordan. There is a lot of water losses and lack of control. So here the MERIC can protect the pumping and the operating of these networks. Specifically, if we are saying of our application here in JVA, we need a control on the inlet of the fats, so we can use the MERIC solution in order to provide all the farmers with a preset quantity of water, regardless of the unauthorized consumption or the association to the water network. In the industrial sector, it can be used in the firefighting, safety shower eye for the wash equipment, which is related to the cleaning and hygiene, cooling tower and equipment, chemical dosing, vacuum pump, dust suppression system, power station, boiler and sprinkler controller, and the fertilizer dosing and chemical process through the industrial application. Finally, it can be used in the domestic and commercial. This can be benefited by the end user and customer side level, which is related to the appliances and fixture inside the household, starting from the showers, kitchenette, and ending by the water heater and toilet applications and relevant domestic and commercial use. In the mining, you can use it in different processes, starting from gland flushing, mechanical seal flow control valve, which is very tight and tamper proof, for safety showers, pump protection, dilution of slurry or product, which is very used here in Jordan, conserving the water, treatment, firefighting, and liquid ring vacuum pump seal for the cooling tower. This is a brief for some references in Europe and in Gulf region. The MERIC solution is applied heavily in Gulf region recently by the water utilities companies, which is managing the whole OM contract in Saudi Arabia and relevant regions. The product range can be differ from the insert valve type, the waiver mode, or the screwed valve type. It depends on the infrastructure asset characteristics and the end user requirement. Now I will stop here to talk a little bit in detail why the MERIC solution and flow control valve of this mode have a potential in Jordan. First of all, we have a high level of NRW, and this flow control valve can be used in order to optimize the unauthorized consumption. Sometimes you cannot disconnect all the illegal use connections. So by this solution, you can say it's okay, we can accept the risk of minimal level of unauthorized consumption by providing a preset value in order to allocate water quantity to some neighborhoods or some areas. So it's very effective in this area. The intermittent water supply regime apply a huge and severe challenges, as Engineer Tamer said. It's a very difficult environment to reduce the non-revenue water. MERIC solution and constant flow valve, regardless of the pressure profile across the network, provide high efficient solution in order to distribute water efficiently and without having the burden of OM and demand and supply management issues. Also in Jordan, we have a complicated supply and demand patterns. That means you cannot define the peak demand in Jordan. Sometimes it's at night, sometimes it's at the daytime. This is because of a socio-economic model that's related to our local community here, and it's differ from region to region, north, middle, and the south. So this fluctuating in the supply and demand patterns, specifically when the operator try to align this water quantity, which is already limited, by supplying the water to a huge capital here in Amman through a duration of less than, let's say, 2 or 3 days per week due to the intermittent water supply. This can be an effective solution because you are controlling the flow rate, quantities, and the water supplied across the DMAs and DZs. Water scarcity, it's a problem in Jordan. This is why MERIC solution can limit this problem by providing a specific quantity to be supplied across different water systems. The high energy bill is related to the high non-revenue water and the problem of Jordan that there is multiple sources of water. either it's far away or very elevated at low level. This means we need to pump water through 500, 600, sometimes 1,000 meter, which exert a huge effort by the operator in order to handle this issue. The agriculture uses the half of demand. This is briefly introduced earlier, and we said that this solution can provide a specific quantities for the farmers or the land use demand. Association to the water networks, by this solution you can limit the water quantity that can be slipped into the unauthorized consumption by providing a control to the flow rates that are directly supplied to the end user and customers, and the water use efficiency and conservation need, which is a priority in Jordan, not only on the supply and water utility level, but also at the household level, and the aging infrastructure and demand growth, which is a problem in Jordan historically, specifically over the last 10 years. We have suffered from the refugees flux and different industrial expanding in Jordan. So the Merrick solution provide a flexible environment that it meet the requirement of local business for the water utilities, and at the same time control the non-revenue water through providing a dynamic, highly efficient and life-sustain constant flow control valve that it's not very complicated, not related to high-tech technology, but rather it's invested in the geometry, material composition, and how to manufacture a custom-made control valve that meet the requirement of the end user and the water utilities through providing preset values regarding of the differential pressure before and after. Here we can provide a sample for a project which is a tanker filling station in Gulf region, by which we introduce the problem, and then the custom-made design have been implemented in collaborative mode with the operators in order to have a constant flow rate values that are directly starting from the inlet point to the end user over all the water cycle. Also, there is a sample of project where the high maintenance diaphragm control valve have been replaced, and the Merrick solution act as a pressure sustainer to ensure the equal filling, which is applied for the fairness of distribution. It's no maintenance and self-cleaning product. Also, this sample of one of the project by which we streamline the performance curves and provide high efficient water cycle through the different complicated system in the treatment, by which we control the flow across and under a high spectrum of pressure differential, as all you can see in the performance curve. Finally, I just want to emphasize that in Jordan, due to the intermittent water supply, and because there is, let's say, a distortion in the supply and demand, because sometimes the water reservoirs and allocation storage facilities are placed in areas where the demand is low relatively, and the intermittent water supply apply a huge burden for the operators in order to allocate a proper amount of water to different service area. This solution can sustain through balancing between two themes. First of all, control the water losses, unauthorized consumption, and prove the revenues through controlling the flow inside the meter itself at the customer and bulk side. And on the other side, you can you have a flexible hydraulic model by which you can design a water network with a self-sustained preset values that you can make it in the office through F scenario, through different pattern demand scenarios. And the problem sometimes in Jordan, when we go to the site to operate these models, we fail because there is no control over the network, either from the operators or from the emergency calls that we have in different season and demand peaks. This solution can be applied as a flow control valve through the modeling, and there's a pilot here in Jordan for which we simulate a water network with intermittent water supply, and the problems there is that there's no customer meters because it's a refugee camp, so there is no tight control on the consumption, and therefore we simulate the hydraulic model at the EBS, extended period simulation, and we strategically install this Merrick solution in the model and conduct the F scenario and avoid the issue of critical point that it's يعني historically not satisfied even with placing a huge quantity of water inside the camp. This is because of uncontrolled distribution and fairness in the water supply. By this solution, we try through the model to simulate this case and assume the consumption pattern by the refugees, and then place the Merrick solution in order to ensure fairness in the water distribution, and install some Merrick valves to protect the boreholes that is providing internally the refugee camp. Now we hopefully will go to the next level of implementation, but this is a small demo in order just to provide a showcase for the Jordanian context. Thank you, and sorry for the long
Thank
duration.
you. Yeah, interesting.
Yet. Well, that's good. I know you will ask me. So the valve idea, this the control of the flow, how it's behave when the pressure, when the flow is just changing based on the needs. For example, during peak time or during night time, when we have the first, for example, few hours there is high flow needs, but then there is less needs. How does it behave?
Actually, this is one of the problems that we faced because everywhere in the world, all the trend is to control a constant flow, except for Jordan case. You need a different mode in order to provide a variable demand across the water distribution network. You can make it alternatively through a bypass. Sometimes we face this problem, and we make a Merrick solution here with a custom-made flow rates starting from, for example, let's say, assuming 5 meter per hour at this area. If we need a big demand during a daytime or night flow, we make bypass in order to operate through another wrapper custom-made solution.
So what happens if the pressure in the system goes high?
If the pressure goes high, it can sustain up to the range of the manufacturer
Because
recommendation.
if I want to control the losses, I need to control the pressure.
Exactly.
So if the pressure goes high in the system, it will keep the pressure, but for example, the flow is still same flow,
Yes.
but
no,
the pressure goes high.
Yeah, this can be controlled through a pressure sustained valve. We need to simulate this through the hydraulic model.
Just-
Thank you for your valuable presentations. I am Yazan Abbadi from JWI project, USAID project from CDM Smith. My question to Tamer, through your experience in last years and our experience with the private sectors in Jordan, the partnership with the private sectors in the reduction of non-revenue water, do you think it was a successful experience, or does these or the lessons learned from the last 10 years, the last 15 years, or projects that tendered to the private sectors reflected in your plan in the near future? Thank you.
Thank you, Yazan. First of all, if let me answer in generic, because your question is also on generic about the private sector, particularly with the utility management. So Jordan, for example, did several initiatives even last 15 years on introducing private sector participation. We had the first one in Madaba, outsourcing the billing. Then we have in Karak and Balqa, kind of similar one, outsourcing the billing. The issue, and also we have different forms. Management contract, which I would call it private sector participation, but it's the lowest level. In Miyahona through Lima. And then we have in the north management contract and managing consulting. We didn't succeed at all. But in general, most of them, except Miyahona Lima case, there was difficulty to sustain the result after the contract ended. And the major reason for that is actually both in Madaba, Balqa, and Karak, you outsource the whole billing without having the internal capacity maintained. Once the contract finish, actually what happens, the situation gets not even back to the same level, it's even worse. so the experience was not that fruitful. What's happened in the recent contract, in the performance contract in Amman, as you saw in my presentation, is very clear from the beginning, even before the tender start, that the risk is not really allocated correctly, which will not lead to success contract. That's why the contract, it made some improvement, but not the intended results. And that's related to the way it's still seen that the private sector could come and make solution, which is not really the case, if the contract was not designed correctly for the context and the risk you have. And of course, sustaining. Can you ensure that this can be sustained after this is concluded, which is the main issue in Jordan. And when we talk about private sector participation for utility, is different than facility, like building at wastewater treatment plants or the pumping stations and running it. That's a bit totally different way of managing, let's say, a facility than managing a system. So that's in my opinion, and maybe Iyad can add.
Yes, actually, I agree with Engineer Tamer that the private sector participation should be subjected to more research and development to find out the best fit scenario, which is proven by Engineer Tamer through the focused performance-based contract. Actually, just I want to highlight the challenging of having the private sector fully operated by the water network and fully responsible for the operation, distribution of water, and having the billing control. Actually, before I have been joined to the performance-based contract, I was working with the northern and southern clusters in Saudi Arabia to develop the proposals with the different companies. And I was the NRW water also at that time before awarding here in Jordan. And I was surprised that the foundational work or the familiarization phase, which was 3 months here in Jordan, it's 1 year in Saudi Arabia. So you take 1 year in order to establish the system, familiarize yourself with the SOPs in the water utility, and then go to clean your database. After that, you start to perform. The challenge here in Jordan that you need a lot of investment in order to complete the foundational works. For example, the customer information system, billing data, customer data, it's not accurate. Unknown networks and interconnections between the DZs and distribution networks, nobody know it. There is a lack of coverage to the, let's say, combination model between the investment in the rehabilitation and the improvement in the operation. Sometimes you need to allocate only a huge investment just to replace the water networks. Otherwise, you cannot reduce the water losses, and we face this problem. Also, there is the gray areas in the contract, which is, let's say, confuse both parties, whether the private contractor or the water utility. So I believe that the recommendation from Engineer Tamer is to have a tailored model that combine the both risk associated with the water utility and the private sector that plan to participate in the OM contract in order to balance the risk between both. But if I may recommend something from personal perspective is to try to avoid non-revenue water percentage as an indicator to trigger the OM contract, because it has no added value under the intermittent water supply and to achieve the target here in Jordan. Sometimes we don't need to reduce non-revenue water rather than to improve the OM system. Also, one critical issue that highlighted by Engineer Tamer is the control of water supply and maintain sufficient quantities. The problem in the contracts that is familiar here in the region is that it designed in a financial model the private sector have an assumption that is provided by the client that you have a system input volume of 20 million annually, for example, or 50 million. Now, I am as a financial modeler, say I will reduce non-revenue water from A to B, so I will save a water cubic meters by this. If I supply this quantity of water, I will bring money of this. This is the CAPEX and OPEX model. From starting date, this model is it's a fail because there is no maintain for system input volume. So the whole story is need to rethink specifically that the performance-based contract need to avoid the rigid factors or fixed numbers. For example, there is in the water loss conference that conducted a couple of years ago, there's an experience in Latin America and in Europe from different water sector authorities and utilities. The main factor is the private sector try to improve the water systems through a matrix of indicators. Each indicator can be compensated for effort, whether at the pressure management, meter replacement, infrastructure leakage index improvement, illegal use, whatever. And through a combination of indicators, you can compensate the contractor in order to avoid the whole loss through just having a figure which is non-revenue water, and it's a mislead under different scenarios. Sorry for long, but just coming back to Mr. Jan, I just want to have a small comments. I remember that in energy sector, they are starting from the normal and traditional logic models and go through the fuzzy logical model. Now recently there is some research in the applying the quantum mechanics in the fuzzy logical model in order to have not a binary system or 0-1.
Correct. Correct.
Yeah.
Jan has some response also to your comments.
Yes, to react on the last question, yes, I'm aware of that. And the fact is, the water sector is very much lagging behind other infrastructure sectors. We have to realize this. The fact that, for instance, I did this presentation is an example, an indicator, because the approach is almost mainstreamed in common practice in other infrastructure sectors. So, but you're right, we are learning, but we are catching up, hopefully, that the water sector, but okay, we will see. It is a first go, and I think so far we are pleased with the result, and we'll see how it develops further. But, Mr. Chairman, I would like to react to the two other speakers on private sector. It's too strong, because I cannot stop, because I've been working quite a lot of time in this period, in this area, and I appreciate your presentation. I think it's very interesting. I appreciate your comment on the presentation, which I fully agree with. But, there's a big but. I think that your criticism is absolutely correct. I fully agree with that. But, again, the issue to say that Jordan is unique is not the case. The situation of Jordan in non-revenue water and private sector participation, forget the word Jordan, take the plane and go to India. Yeah. You have exactly the same discussion. Take another plane and go to the Caribbean and you have exactly the same discussion. So the issues and the challenges you face are very important, but they are everywhere in the world, and you will be amazed sometimes to see the same arguments used in the same situation. That's my first point. My second point is you don't blame the private sector for all what is wrong. But there is the two criticisms you say in the, I'm not defending private sector, because I say if you give the public sector the same tools and means as the private sector, there is no reason why the public should not be equally efficient. That's the beginning. Private sector is not an objective, it's an instrument. Okay, having said that, the issue of sustainability is absolutely recognized, and it is a challenge, and we have problems to solve it. I can give you an example to support what you said yourself. In Jamaica, there has been a PBC for non-revenue water. The starting point was in percentage, excuse me for the percentage, was 75%. at the beginning of the contract. At the end of the contract, it was in the order of magnitude of 40%, good. But 1 year after the contract, it was even worse than 75%. The sustainability issue is an issue. But don't blame the private sector for that, because it is the conceptual design of the partnership which is to be blamed. Exactly. And we have to, and I can say this although I'm not part of the family, but a lot of the consultants are on the learning curve. Okay? Sure. And what we are missing in the consultancy family is perhaps people which come from utilities, understand what this is all about, operating a system, so that the sustainability challenge can be addressed in an appropriate way in a contract. And there are ways, and it is coming, it's not there, but it is not correct to say a priori it is not good. There are solutions already developed in the world, and I think it is a debate for another session perhaps, to see. My second point is, and there I was really upset when you say about this calculation of the incentives. That is, if that is the case, then you should really have a problem with the consultant who had developed the bidding documents. Because the current practice is that in the new tender documents for any format of modality of PSP, the issue that you raise is critical. And we should have a method of calculation of the indicators, and the incentive structure related to that needs to be simple, enforceable, transparent, and all what you want. If a contract has not fulfilled this precondition, we have an issue. And I can tell you one thing, if the contract is not good, it will be definitely a failure. A good contract is not really an assurance that it will be a success, but guaranteed, if the contract is not well done, it is not going to happen. My third point is, and that is also, but as a personal experience, you should still think twice by using the private sector in an outsourcing function. If you outsource in isolation the billing, or the O&M, or something else, it's complicated, and I would really advise to think twice before you do this. But that's a debate. And this I perhaps would suggest to the Aqua to have a session, because the subject is so interesting, and we really need to find solutions, because we cannot go on like we do. Sorry, that's my personal reflection.
Thank you very much for this conclusive remarks on the issue. I would like to thank the respected speaker, Mr. Tamer Al-Asad, Mr. Jan Johnson, and Mr. Iyad Sahawn. I would like to thank the audience and the people who raised questions. With this, we conclude this session. Thank you very much. It's a pleasure seeing you all.
Thank you.